Hi friends, we may wonder how these holes are made in such metal rectangular plate. If your answer is handle, it's not exactly correct. The answer is the 3 HP powerful beast called Radial drilling machine. Now we are going to see the components of this radial drilling machine. Before that, we have to see the principle working behind in this process. Basically, a workpiece is consider this workpiece. The principle on this process is based on shearing and extrusion process. The tool used for this device is called radial twisted drill. The twisted drill has specific features, and when it it revolves and it is pushed in downward direction, the metal is removed in a workpiece by shearing operation under the extrusion process. The extrusion means the chips will be removed in the process of extrusion. Now we are going to see the components of this radial drilling machine. First, the bed and this column, then radial arm, spindle motor, spindle head, and this is also called as drill head, RPM selector, hand wheel, and up and down switch button, table, and this is elevating screw, which is very essential for this radial drilling machine, and this is coolant motor. This is used for elevating screw purpose for up and down motion. This motor is very helpful.
Then what's about that?
It consists of 3 levels plus 1 lever. This I will explain the functions of each and every lever. First, the bed. Bed is made of rectangular casting, which is used for withstand all the forces and vibrations acting on it. And it is a rectangular casting. So this is the column, which is made of cylindrical casting, which is used for connecting this radial arm with this column, and the elevating screw, which is a square form of circular thread, and it is used for downward and upward motion of the radial arm. Then the spindle head, this head is connected to the spindle motor, and this motor transfers the power to the twist wheel, which is to be fixed in this position. So when the motor rotates, we have to select the RPM, and the twist wheel will be rotated at the required speed. Then this wheel is used for the vertical feed for the movement of twist wheel in downward direction, and this is nothing but the on and the upward downward motion, and the on off button used to initiate the machine. And this is the forward and the reverse gear, which is used for the rotation of the twist drill in forward direction and reverse direction. And this motor, elevating motor, this elevating motor is very essential, which is used to lift the entire fixture of radial drilling arm to upward or downward direction. This coolant motor, when operated in semi-automatic mode, used to supply the coolant automatically. Then this is nothing but the main box. For every device there should be a main box, and here it's stable, which is used to hold the workpiece very firmly and rigidly. It has very fine T slots made accurately. I will explain the purpose of these T slots next. And here is the bed. The bed also consists of T slots. Okay, now we are going to see the functions of these components of radial drilling machine. The bed is as I already said, it's used to withstand all the forces and vibration while operating the radial drilling machine. Basically, it is based on rectangular casting. And then table is used to hold a workpiece with these work holding devices. Now, basically I said there are 3 plus 1 small lever. The first lever is used. This lever is used for the movement of upward direction of radial arm and downward direction. When it's closed, there will be no movement. When it is in open, the rotation of the arm will be takes place. For example, if we rotate, it will move. Then this is for horizontal feed. When we want to move the machine from this left to right or right to left, so this will be used. And this lever, as I already said, used to rotate the twist wheel in forward or opposite direction. Most probably the forward motor will be used. The reverse is not used in most of the cases. And here is RPM selector. We have to select the speed of the twist drill based on the workpiece we are using. This should be taken from the machining data book. For example, this workpiece is made of mild steel rod and HP should be ranged from 25 to 30 meter per minute. And for that speed, we have to select the necessary RPM from the formula V equal to pi dn by 100. The D is the diameter of the twist drill. Here it's not present, but we should fit this in the diameter of the twist drill hole. And RPM selector, we have 1, 2, 3, 4, 5, 6 speeds with 2 ranges, lower speed and the higher speed. For a necessary speed from the necessary speed calculation, we choose the appropriate speed. And for high speed, this should be used from this gear, which is the lever should be moved to higher position for using higher speed, and for lower speed, this lever should be pushed down for lower speed. Then now we are going to see the basic working principle. How should we produce such holes on the workpiece? First and foremost, we should fix the workpiece in this position using the lever. Using this, we have to adjust in this direction. And once the workpiece has been framed tightly, we have to fix the position of the twist drill should be at the point where we want to make hole. This should be done using the radial arm movement, which should be moved for the required position, and the horizontal feed should be given to for the required position. And then the third important thing is to move the twisted drill in on position, that is rotating mode, and we should move the twisted drill in downward direction for the formation of chips and the removal of material. This should be when using this feed, and the feed calculation should be done based on some formulas. Then we are going to see about work holding devices and various types of tool holding devices. Tool holding devices are nothing but there are majorly 5 different types of tool holding devices. When this is the twisted drill hole, when this hole is equal to the twisted drill hole, then we can directly fit the twisted drill into the spindle hole. When the spindle hole is greater than the twisted drill hole, we have to use drill sleeve. In the other sense, when the twisted drill hole is smaller than the twisted drill, we have to use drill socket. And sometimes chucks are also used. 3-jaw chucks, 4-jaw chucks are also used. And then sometimes for tapping operations, special attachments are also inserted in this point. Then in the sense of work holding devices, there are majorly 6 to 7 work holding devices. Some of them are, first this is called a drill press vise, because we have to press, we have to one jaw is fixed and the other jaw will be movable. We have to use this lever for rotating and pushing the jaws and for holding the workpiece firmly. And the other is angular plate, which is in L-shaped direction 90 degree. If this is the workpiece, then we have to insert in this direction, and using the molds and clamps we can fix. And V-blocks will be in this direction. A rounded workpiece will be held for these purposes. And step block, when we use our workpiece which having stepped edges, we can go for step blocks. And T-bolts and clamps is most commonly used, and we have to insert components. We have to hold the workpiece here, and T-blocks should be inserted here, and the bolt should be clamped. This is seen here because they are using for bed to connect with the table. They are using here is T slots, and the T-bolts and the clamps are used here. This is one very good example for such T-bolts and clamps. Also, one of the major advantage of using lead, they are sometimes used to collect the chips, which are sometimes continuous and discontinuous chips can be collected. Also, coolant should be used and gets collected here. In semi-automatic mode, feed and coolant should be supplied automatically. In manual mode, we have to separately supply the coolant, and the coolant will be left here when it's applied here. Then what to say? Yes, we have so far seen the basic working principle of how to make these holes. Now we have to see the various operations performed with this beast radial drilling machine. Is it can drill the material, drilling, boring, reaming, and counter boring, counter sinking, pre-panning, spot facing, and tapping operations. These are the operations, frame operations, which can be performed using this radial drilling machine. Now clearly watch or examine this workpiece. Here there are 4 drilled holes, and here one big larger diameter drilled holes are used. Then this is called drilling. When we are not having the diameter of twisted drill for other than standard sizes, we have to go for boring operations, which should be used by boring tool. And this is some thread like structure is this is called tapping operation, and this is called counter sinking, and other counter boring operations are also available. Now in short, I am going to say basic operations and their functions are for the purpose of that using that operations. Drilling, we are already used to drill that hole, and counter boring when we are going for larger diameter, the twisted drill are not having in standard sizes, and counter boring is used for provision for alignment of square bolt, and counter sinking is nothing but this is used for proper alignment for screws and bolts, nuts, etc. fasteners. Then spot facing is nothing but when the surface is inclined in direction, we have to make hole in proper horizontal axis, then we go for inclining. Then reaming is very essential when we go for drilling and counter boring operation. The internal surface finish, you may see here, the surface finish in the internal hole is not very good. Then this should be, if you want very good surface finish, then we go for reaming operation. Then we have to conclude this video. I hope you have great knowledge on this video. Thanks for your worth of 5 minutes.